Hey everyone, Lindsay here, and today we're going to talk about cell division, and more specifically, let's talk about mitosis. So let's have a go. So here's mitosis, but let's start with something a little bit simpler. I'm sure most of us have all had a paper cut at one point in our lives. Sometimes they feel like the whole world is going to end, right? They hurt just so much. So what do? Well, for me, I put a Band-Aid on it, and a few days later, bam, it's gone. Cool, right? But have you ever wondered how it does that? How it heals? Here's something else to look at. Take a look at your nails. Ever wonder how they grow? You just cut them a few days ago and you can already see they've grown, right? So what do these two examples have in common? Well, you guessed it, mitosis. So mitosis is a type of cell division, and most of our cells throughout our body are undergoing mitosis. And if they didn't, then you wouldn't be the size you are today. Mitosis is also great for damage, like that cut I talked about earlier. Well, your cells make sure that it gets repaired by making more cells. But before we go any further, I need to tell you what mitosis is not. Mitosis is not meiosis. Even though they sound familiar and maybe even look familiar, they're very, very different. Mitosis produces identical cells. Meiosis produces sperm cells and egg cells. But let's save that for another time. Mitosis produces body cells, identical body cells. So liver cells make new liver cells, and skin cells make new skin cells. The cells are being produced to replace damaged or worn out cells, but the key is to be making identical cells. Cells are not undergoing mitosis all the time. If we take a look at this cell cycle, mitosis is only about 10% of the cycle, while the other 90% is interphase, where the cell grows, replicates its DNA, and completes its other daily functions. Even though mitosis is a small portion of the cell, it's extremely important. So we all know that every cell in our body has a nucleus, which contains our DNA. But have you ever thought about how much DNA we have? There's a lot. And if you were to lay it all out and stretch it out, it would be about 2 to 3 meters long, aka the height of your own body. Pretty cool, eh? Anyways, to go through mitosis, a cell must organize all that DNA into chromosomes, which in most of your cells, there are 46 chromosomes. Before mitosis can even start, you must duplicate those chromosomes, which happens in interphase. So you're probably wondering why I'm showing you SpongeBob right now, but maybe he can help us. Maybe you know the fun song.
Let me spell it for you. F is for friends who do stuff together. U is for you and me. N is for anywhere and anytime at all. Down here in the deep blue sea.
So let's see if this sounds familiar.
P is for prophase, M is for metaphase, anaphase comes after that. Telophase is last before cytokinesis divides the cytoplasm.
Alright, so that was fun, right? Alright, let's recap the 4 stages. So the first phase is prophase. The nucleus is still hanging around, and the chromosomes condensed and become visible. Next is metaphase, which is when the chromosomes line up in the middle and the spindle fibers attach, all while the nucleus has been broken down. Next is anaphase, when chromosomes are pulled apart into their separate chromatids, moving towards the poles of the cell. And finally, the last state is telophase, where the chromatids are at the poles and the new nuclei are formed. Nuclei, you're probably wondering, what's that? Sounds like nucleus. Well, it is. It's just the plural word for it. So now you're probably wondering, well, there's one cell, kind of looks like almost 2, and there's 2 nuclei. That's a little strange. Then comes cytokinesis. Cytokinesis is responsible for splitting the cytoplasm. And there you have it, 2 identical cells. So, remember back to the start of this video and how I asked you how your nails grew or how your cuts healed? Well, this should give you an idea at least. Mitosis is responsible for the growth and repair of your cells when needed. So there you have it, mitosis, cell division. Now I want you to imagine uncontrolled mitosis. What would this look like? Well, kind of like this. So on either side, you see what normal cells look like. But what's going on in the middle? Give this some thought and let's chat soon. Thanks for watching. See you next time.